Continuing Lesson 19, Integration of Rational Functions. The last video we discussed how to break down one fraction into a sum of partial fractions. For this example, the denominator is a difference of two squares, so I already broke it down as 2 plus 3x times 2 minus 3x, and have already written the partial sums. Now we need to find a and b respectively. So what we do is bring down our beginning problem. Bring down your fractions. And actually our common denominator is 2 plus 3x times 2 minus 3x. So what we'll do next is take our common denominator and multiply it times each fraction. And we'll go fraction by fraction, cancel out stuff. And then write what's left over. So the first fraction, everything cancels, leaving us with just 1. Second fraction, the 2 plus 3x's cancel, leaving us with a times 2 minus 3x. And at the end, the 2 minus 3x's cancel, leaving us with b times 2 plus 3x. Now you can set the coefficients equal to each other and find a and b that way, or you can use zeros to help you. What would make this first binomial 0 is if x was just positive 2/3. So let's plug in 2/3 everywhere we see an x. So we have 2 minus 3 times 2/3. Plus b times 2 plus 3 times 2/3. And in both cases, the 3's cancel. 2 minus 2 equals 0, so that part is gone. Here the 3's cancel. 2 times 2 is 4, so that will give us 4b. So b is equal to 1/4. We can do the same thing to find a. Just go back to your original equation. We have 1 equal to a times 2 minus 3x plus b times 2 plus 3x. Well, what would make this x here or make this expression 0 is when x is negative 2/3. So everywhere we see an x, plug in negative 2/3. In both parentheses, the 3's cancel. Here, that will give you 2 plus 2, or 2 minus a negative 2, which is 4. And here the 3's cancel. 2 minus 2 gives you 0. So the entire thing second part cancels. So A is equal to positive 1/4. Now that we found A and B, we can plug those in and integrate our partial sums. So we have A over 2 plus 3x plus B over 2 minus 3x. And A and B were both 1/4. So we got 1 over 4 times 2 plus 3x plus 1 over 4, 2 minus 3x. And now we're ready to integrate. For the first fraction, let u equal to 2 plus 3x. So du is equal to just 3 dx, or that's the same thing as 1/3 du equal to dx. And for the second fraction, let u equal to 2 minus 3x. So du is equal to negative 3 dx, or that's the same thing as negative 1/3 du equal to dx. Let me erase the u's and du's and actually plug them into each fraction now. So we had 1/3 du, so 1/4 times 1/3 is 1/12. Du. The other substitution we had negative 1/3, so that will be 1/4 times negative 1/3 or negative 1/12. U again, du. And we know the integral of 1 over u is natural log. So we have 1/12 natural log absolute value of u minus 1/12 natural log absolute value of u again plus c. And the last step, when we back substitute what u originally was for each fraction, we have as our final answer 1/12 natural log excuse me, 2 plus 3x minus 1/12 natural log absolute value of 2 minus 3x plus your constant c. In the next video, I will show you another example involving partial sums.